All right, in this video, we're going to multiply binomials and trinomials. Sometimes the binomials will be first. Sometimes the trinomials will be first. But remember, they're being multiplied, so you can just use the commutative property. I like to put the binomial first. So here we go. Our problem, we have a binomial times a trinomial. So I have negative 6x times negative 2x squared, which ends up being a positive 12x squared. So instead of recopying the problem on paper, you could do that. I'm just going to multiply the first term of the binomial times the first term of the trinomial. Now I'm going to take, I should use a different color, so I did this times this. Now I'm going to take the first term, negative 6x, times the middle term, which would give me a negative 6x squared. So I have plus negative 6x squared. And then I do that negative 6, first term of the binomial times the last term. And if you do it in an orderly fashion, you'll make sure you've distributed every term in one to each term in the other. So that would be a positive 6x. All right, now I'm going to go to the second term, the 6 times the first term of this trinomial, being negative 12x squared, so plus negative 12x squared. Then 6 times x, which is 6x. And then the 6 times a negative 1, which is a negative 6. Okay, and I think I got that right. Yep, did that. So I have a lot of terms here. And I change everything to addition except for this last one. And I'm looking for like terms. I'm looking for x squareds. Looks like we have 3 of those. But actually, when I multiply the negative 6x times negative 2x squared in the very beginning, I should have had x to the third. So I will erase that. Caught my mistake ahead of time. So therefore, I have only one x cubed term. I have 2x squared terms, so I add the negative 6 and negative 12. I get negative 18x squared. I can just make that minus 18x squared. I have 2 x terms, so I end up with positive 12x. And I have plus negative 6, which is the same as minus 6. So I'm going to see if this works. Time to check. Quick inspection of what I got here. I already caught my first mistake when I didn't put the correct exponent. So I have it there now, and I've typed in a 3 over here. So everything looks good, I think, anyways. Let's see what I get. Again, the reason for the hearts, it's Valentine's Day weekend when I'm making this video. Let's go to another example. Now, in this example, the trinomial is written first, the binomial second, which is fine. You could just flip them around if you want to use it in commutative property, or you could just do it as follows. Use my blue pen, so I take the first term here times the first term there, be 24x to the 6th. Plus, let's stay with the first term. First term times the second term would be 12x cubed. 12x cubed. Now I go to my second term here. Opposite of x times 4x cubed be negative 4x to the 4th. Opposite of x times 2 is negative 2x, or plus negative 2x. And then finally, this last term here, 6 times 4x cubed is plus 24x to the 3rd. And then the 6 times 2 is plus 12. I have powers, x to the 6th power. So there's only 24 of those. I write that first because we'll write these in descending powers. I have an x to the fourth term. That's the only one I have of those, I believe. Yep. So I write negative 4x to the fourth. I could keep it as plus the opposite. Don't have to. Now I have x cubes. I have 12 of those, and 24 gives me 36 x cubes. Any x squared terms? Nope. So I go right to the x's I have. Negative 2x. So I just put negative 2x plus the 12. I'm going to type this in here. It's check time. Again, quick inspection of what I have here, what I have here. Think I got it. Nice. All right, do your best with those. Take your time. Make sure you distribute correctly. Look for your exponents, make sure they're correct. Get negative signs. Combine like terms, if there's any, with the same variable and same exponent. Good luck.